Good afternoon and welcome here on the Red Couch, live at Electronica in Munich. My name is Michael Brunn, I'm the editor-in-chief of the E&E magazine. And during the whole trade show, we will talk with important people from the electronics industry about topics that are moving the industry. And you can watch us live here at the trade show or later on via YouTube or our Facebook channel. And right now, my guest here at the Red Couch is Wolfgang Heinz-Fischer, Head of Marketing and PR from TQ Group. And we will talk about core technologies for the smart grids. Welcome, HiFi, as he is known in the industry. Smart grid is currently a hot topic, otherwise we wouldn't sit here and talk about it. So how does it work? Sounds simple. Is it that simple?
It's basically, it's simple. The major problem is a communication problem. So the grid has to know where power is generated, where power is used, where power is be stored, maybe in the future, to organize the overall consumption and distribute it to the right places. The major problem, or in the past, was easy because the use of power was very statistically known by the generators, by the power companies. So they was able to bring in their power plants up and down due to the need. But by the new energies like solar cell, like wind turbines, nobody knows when the wind is blowing, when the sun is shining. So that's influencing a lot the supply of power, and that cannot be managed so well at the moment. So that's the most critical part, to know where power is generated, to become an intelligent distribution of the power.
Mm-hmm. And so what is the current situation about the smart grid regarding those aspects?
Basically, the very high voltage systems and networking, they are connected, so they know exactly what's going on, if the transformer is working, if the switch is on, and these things. But if we see then the mid-size and the low end, there's no communication, there's nothing there. Basically, the technology will be easy, but of course needs a political willingness to implement that and to save energy at the end of the day. But the power generators and power companies want to sell more power, so they're not really interested in to make that happen in the market.
Mm-hmm. So you mentioned the power suppliers, big players in this area, so why does TQ think that it's worthwhile to get involved in the smart grid?
Yeah, we believe that sooner or later the customer will make some pressure to the suppliers because the costs are rising and it's getting more expensive. So that's the only pressure which is working in the market. So as we're expecting that sooner or later power suppliers will try to optimize their payment system, so they offer lower prices if energy is available and higher prices if no energy is available. So they're forcing the customers by pricing to align themselves to use the power if the power is there. For example, if the sun is shining or the wind turbine is working, then open your or start your washing machine or do some cooking, things which you not necessarily has to do at the same time or at a dedicated time. So, and that needs, of course, the knowledge from all different points, needs the communication, where power is there, where power is needed, where power can be stored, and that's basically the grid, and that needs a basic core technology to do the basic communication.
Mm-hmm. So, I see you brought something here with you. What kind of products and solutions is TQ is offering regarding the smart grid?
Yeah, basically we have different items in the grid, which might be a battery, which is a transformer, which is a switch, which is a lot of things which has different signals to communicate and which is necessary to communicate in the grid. So what we developed, it's a very tiny module which can be core of the grid. And the used processor, it's an ARM9 processor from Freescale, which has a hell of interfaces which may be needed. So starting with analog digital converter, So we have some analog signals has to be converted to communicate in the grid. We have USBs, so there might be some sensors which is connected by USB. There's a serial interface, so we may have some serial interfaces, and some other digital I/Os, so relays or whatever can be connected directly to the board. The board itself has 2 times Ethernet, so this will make the communication into the grid, and the rest can be done simply by that device. At the end, in the long run and the long-term thinking, the device makers itself, is there some electronic inside? Of course, they will implement these kind of little communication module inside their electronica. But at the starting point, we see they need a box somewhere beside the transformer, beside a switch, beside whatever, and they need a very simple one. So inside, it's the important stack, which is the IC 61850 stack. It's implemented in that board, which does the basic communication. And as I said, we have all the signals available. Simply make a carrier board or small box, bring out the connectors to the dedicated signal which is available in that part of the grid, and the rest is standard, communicate to the next level.
Talking about availability, when are those solutions available? Are they?
Yeah, of course there are a lot of switch boxes, data communicators, etc. But these are most of the time it's coming from the IT sector, so it's not really prepared for the industrial use. So transformer is somewhere outside. There's a minus 20 to plus 50 degrees, and so the IT components will not really fit in that. So we need an industrialized version. We need a version which can run in industrial environment and will be available on the long term, so not changing that device all the time. So the customers want to have that for 5 years, 10 years, or even longer. So that's another demand, and of course price issue. So the price issue, if you take the IT, some kind of switch, which will be in industrial range, we're talking about maybe 200, 300 euro. And here we're talking for the basic for 50 euro, and we can come down even lower than that, and simply put a little box around. So we definitely are far below the 100 euro price range, and that's the demand in the grid.
So this is the embedded side. TQ is also known as a company offers electronic engineering and manufacturing services. What support can you provide for customers in the smart grid area?
Basically, we do full customization, so we have technology and providing technologies in the direction of inverters for the solar energy or industry. We have some design made for the more local use of power, because that's again one possibility to save power, not generate by your solar cells, transport it into the grid, and then take it back from the grid. Why not store it locally? So there's one system which has battery, which has a full control and a bidirectional DC converter. So that was designed and manufactured by TQ. So the solar energy will be locally used. If the battery is full, still sun is shining, it will be fed to the grid. If the battery is empty, then we have to get power from the grid. But the battery size is calculated that for a 3-person household can organize 95% of the power by that system. So that will one of the directions how to save energy, not transport too much, and the cost for the total system is calculated by something like 16 cents per kilowatt, so which is much lower than what you pay these days. So the investment will be paid back definitely.
Coming back to what you said to the first question, which steps should be taken to accelerate the implementation of the smart grid? For example, what can the industry do, what can the government do, and what can the customers do?
Yeah, we was on the roof under the smart grid arena, which was organized by the German government, and we've seen a lot of customers who is willing to start, but they see the political willingness and the political environment is not really there. I think that's the key, that there must be a clear message, and the latest message in the revolution. It's okay. Look to your power consumption and see where you can save it. Buy a new washing machine. That's not the solution. that's giving back to the,
no revolution.
No revolution. That's giving back to the ordinary people. That's not really take it from the scratch and not taking at the source. So that needs a really political change in the direction of take it serious. Force the power generators and the power companies to think about to take smart grid serious and really implement it into the market.
Okay. Final question. Your opinion, short answer. What will the near future bring for the smart grid?
It will come and it must come, and it will come definitely.
But when?
Let's see the next election.
It's always a good answer. Thank you very much, ladies and gentlemen. This was the Red Couch Talk about core technologies for smart grid, live here from Electronica. I'd like to thank Wolfgang Heinz-Fischer from the GQ Group for joining us and giving us some insight on this topic. And thank you all very much for watching and listening. We wish you all a successful trade show. And if you are interested, you will find this interview and all the other interviews we will have throughout the Electronica on Publish Industries YouTube channel. Thank you very much.
Thank you.